Dear students, Namaste. I am Subodh Kamble from SBNM College of D Pharmacy, Maha. In this video tutorial, I will discuss the classes and functional groups in organic compounds. Before starting the tutorial, I wish to acknowledge my sincere gratitude to the respected Dr. Prashant Argade sir, Senior Lecturer, Government Polytechnic, Department of Pharmacy, Jalgaon, for their valuable encouragement for making this video. I also acknowledge the reference of a textbook of organic chemistry by Arun Bhal and B.S. Bhal. After watching this video, the students will be able to explain functional groups, distinguishes the classes and functional groups of organic compounds, elaborate polyfunctional compounds, and know the decreasing priority order of functional groups for nomenclature. Functional group is an atom or group of atoms in a molecule that gives the molecule its characteristic chemical properties. For example, N-butanol. In this structure, you will see dash OH group is attached to the basic structure of butane, replacing one hydrogen with OH. The OH group is known as functional group and the remaining portion containing only carbon and hydrogen called as hydrocarbon portion. The hydrocarbon portion can be represented by using symbol R to which the functional group is attached. Functional group is the action group and important for three main reasons. That is, it is the basis for nomenclature of organic compounds. These are important for classifying organic compounds, and a functional group is a site of chemical reactivity in a molecule. Now, we will see the various classes of organic compounds with their functional group. The alkenes contains carbon-carbon double bond, for example, ethene. The next class is alkynes, which contains carbon-carbon triple bond in it, for example, ethyl. The alcohols, which contain dash OH, that is hydroxide group in their structure, for example, ethyl alcohol. See, here in all examples, I have taken the basic examples of the respective class. The aldehydes have the structural formula RCOH and the example is acetaldehyde. See, in the formula of aldehyde, the carbon is attached to a hydrocarbon portion on either end and the remaining bond is attached to a hydrogen and oxygen. The next class is ketone having formula RCOO dash, and the example is dimethyl ketone or acetone. See the structural formulas of aldehyde and ketone carefully. You will observe that both the structures are same and quite confusing. So remember that in aldehyde the hydrogen is always attached to C double bond O group, and in ketones the hydrocarbon is attached to C double bond O group. Both the hydrocarbon portions are maybe same or different. Carboxylic acids have the structural formula RCOOH, that is C double bond O, and OH is attached to it. For example, acetic acid. The next functional group is ether, having formula ROR dash, represents the hydrocarbon portion. For example, dimethyl ether. The esters have the structural formula RCOOR. For example, ethyl acetate. In this structure, the methyl group is attached to either end and ethyl group is attached to another end. The amines are those compounds that contains dash NH2 group attached to hydrocarbon portion. For example, methylamine. The amides have the structural formula CONH2. For example, acetamide. When you observe the structural formulas of amines and amides, you will see dash NH2 group is present in both class. But always remember that in amines only NH2 group is present, and in amides NH2 group is attached to C double bond O group, and in some cases the nitrogen may attach to different hydrocarbon portion. Alkyl halides is the class of organic compounds in that the halogens, that is fluorine, chlorine, bromine, iodine, are attached to hydrocarbon portion and denoted as symbol X. For example, ethyl bromide. See, in this, bromine is attached to ethyl group. In ethyl chloride, the chlorine is attached to ethyl, and in ethyl iodide, the iodine is attached to ethyl group. Sulfonic acids have the structural formula R-SO3H. The example of this class is ethane sulfonic acid. The next class is nitro compounds, that is those compounds containing nitrogen and have the formula R-NO2. For example, nitromethane. In cyanides, CN group is attached to hydrocarbon portion. For example, methyl cyanide. These are the various functional groups. Now we will see what are polyfunctional compounds. A compound that contains two or more different types of functional groups are known as polyfunctional compounds. The functional group which specifies its class known as principal functional group and the other functional groups are referred to as substituents. For example, 3-hydroxybutanoic acid. When you see the structure, you will observe that there are two different functional groups are attached. The alcohol is attached at third position and the carboxylic acid group is attached at first position. By following the order of priority of functional groups, the carboxylic acid group is called as principal functional group and alcohol is called as substituent. The list of functional groups in decreasing priority order for nomenclature is given for your references. Table also contains the prefix and suffix which will be used while naming the chemical compound. Thanks for watching this video. Your comments and suggestions for improvements are welcome. Please do subscribe to the YouTube channel for more videos.